Hello, everybody. It's me, Code Tucker Looter, in another episode of the Beginning JavaScript. And as I said before, this is going to be an hour long, 50 to 60 minutes long video about this particular course. I'm going to try to make two other to put them in the next um, uh, you know day of the release date of the next course of the JavaScript course. So let's try now with the switch statement. So we found the elif statement in the JavaScript now, and this is the switch statement. So let's get going into the course. The switch statement. You saw earlier how the if and else if statement could be used for checking various conditions. If the first condition is not valid, then another is checked, and another, and so on. However, when you want to check the value of a particular variable for a large number of possible values, there is a more efficient alternative, namely the switch statement. The structure of the switch statement is given in figure 3.7. So the switch my name, for example, case Paul, checking for possible values if match is found, some code, break. Case John, some other code, break. Default code, and the break. The best way to think of the switch statement is switch to the code where the case matches. The switch statement has four important elements: the test expression, the case statement, the break statement, and the default statement. The test expression is given in the parentheses following the switch keyword. In the previous example, you are testing using the variable my name inside the parentheses. However, you could have any valid expression. Next come the case statements. The case statements do the condition checking. To indicate which case statements belong to your switch statement, you must put them inside the curly braces following the test expression. Each case statement specifies a value, for example, Paul. The case statement then acts like if my name is equal to Paul. If the variable my name did contain the value Paul, execution would commence from the code starting below the case Paul statement and would continue to the end of the switch statement. This example has only two case statements, but you can have as many as you like. In most cases, you want only to block of code directly underneath the relevant case statement to execute, not all the code below the relevant case statement, including any other case statements. To achieve this, you put a break statement at the end of the code that you want executed. This tells JavaScript to stop executing at that point and leave the switch statement. Finally, you have the default case, which is the code that will execute when none of the other case statements match. The default statement is optional. If you have no default code that you want to execute, you won't leave it out. But remember that in this case, no code will execute if no case statement matches. It is a good idea to include a default case unless you are absolutely sure that you have all your options covered. I will go into example here. Cool. So we go for chapter 3, sample 3 at HTML. Let's go. Doc type, HTML, lang English. We got the head as we got the head. We got the title, chapter 3, example 3. We got the body and the script. Variable secret number. You use the prompt, pick a number between 1 and 5, and then use a comma. All right. Secret number is equals to parsed integer secret number. Oh, sorry, no parentheses here. Okay, I'll go to switch statement. Secret number. We'll go for case one. The case one is going to be document dot write. I'm going to write too low. Okay, the break. Break. We're going to make a case two right here. Case two document dot write too low again. Okay. Then we break case three document dot write you guess the secret number and then break. Case four um, case four document that write too high, then put break. Yeah, see, weird that it doesn't, it doesn't how you call it, like arrange the tabs by each other by itself. Go again for case five document that write too high. I'm gonna put it in lowercase just to see if too high. Fault document that write you did not enter a number between 1 and 5. Semicolon. We also gonna get one out of the switch statement. It's gonna call document that write bracket break line the space over here. Execution continues here. All right, we save our file, go to the folder, pick a number between 1 and 5. 3. You guess a secret number. Let's go. This is easier. Okie dokie. Okie dokie. Okay, now let's read. Load this to your browser and enter, for example, the value 1, and it's going to be too low. If, on the other hand, you enter the value 3, you should see a friendly message letting you know that you guessed the secret number correctly. First, you declare the variable secret number and set it to the value entered by the user via the prompt box. Note that you use the parse integer function to convert the string that is returned from prompt to an integer value. Next, you create the start of the switch statement. The expression in parentheses is simply the variable secret number, and it's this number that the case statement will be compared against. You specify the block of code encompassing the case statement using curly braces. Each case statement checks one of the numbers between 1 and 5, because this is what you have specified to the user that she should enter. The first simply outputs a message that the number she has entered is too low, right? The second statement as well, and the case 3. Finally, the fourth and fifth case statements output a message that the number the user has entered is too high. A default statement is also very useful for picking up bugs. If you have coded some of the case statements incorrectly, you will pick that up very quickly if you see the default code being run when it shouldn't be. Finally, you have added the closing brace indicating the end of the switch statement. Executing the same code for different cases. You may have spotted a problem with the switch statement in this example. You want to execute the same code if the user enters A1 or A2, and the same code for A4 or A5. However, to achieve this, you have had to repeat the code in each case. What you want is an easier way of getting JavaScript to execute the same code for different cases. Well, that's easy. Simply change the code so that it looks like this. Secret number, case 1, case 2, okay, case 3, okay, okay, okay. So you put the two cases in one particular break. If you load this into your browser and experiment with entering some different numbers, you should see that it behaves exactly like the previous code. Here you are making use of the fact that if there is no break statement underneath the code for a certain case statement, execution will continue through each following case statement until a break statement or the end of the switch state is reached. Think of it as a sort of free fall through the switch statement until you hit the break statement. If the case statement for the value 1 is matched, execution simply continues until the break statement under case 2. So effectively, you can execute the same code for both cases. The same technique is used for the case statement with values 4 and 5. Looping the for and while statements. Looping means repeating a block of code when a condition is true. This is achieved in JavaScript with the use of the two statements, the while statement and the for statement. You will be looking at this shortly, but why would you want to repeat blocks of code anyway? Well, take the situation where you have a series of results, say the average temperature for each month in a year, and you want to plot this on a graph. The code needed for plotting each point will most likely be the same. So rather than write the code 12 times, it's much easier to execute the same code 12 times by using the next item of data in the series. This is where the for statement would come in handy because you know how many times you want the code to execute. In another situation, you might want to repeat the same piece of code when a certain condition is true. For example, while the user keeps clicking a start again button, in this situation, the while statement would be very useful. The for loop, the for statement enables you to repeat a block of code a certain number of times. The syntax is illustrated in figure 3.10. Okay, so the for loop counter, okay, is equals to 1. The loop counter is less or equal to 3, loop counter plus plus. Execute this code. Code looped through. Let's look at the makeup of a for statement. You can see from figure 310 that just like the if and switch statements, the for statement also has its logic inside a parenthesis. However, this time that logic is split into three parts, each part separated by a semicolon. For example, in figure 310, you have the following. Var loop counter equals to 1. Loop counter, okay, same sample. The first part of the for statement is logic, is the initialization part of the for statement. To keep track of how many times you have looped through the code, you need a variable to keep count. It's in the initialization part that you initialize variables. In the example, you have declared loop counter and set it to the value of 1. Sorry about that. Vibrate only. You don't need to declare the variable if it was declared earlier in the code. Var loop counter, for loop counter. Following the semicolon, you have the test condition part of the for statement. The code inside the for statement will keep executing for as long as this test condition evaluates to true. After the code is looped through each time, this condition is tested. In figure 310, you execute for as long as the loop counter is less than or equal to 3. The number of times a loop is performed is often called the number of iterations. Finally, you have the increment part of the for loop, where variables in your loop's test condition have their values incremented. Here you can see that loop counter is incremented by 1 by means of the plus plus operator you saw in chapter 2. Again, this part of the for statement is repeated with every loop of the code. Although we call it the increment part, it can actually be used to decrease or decrement the value. For example, if you wanted to count down from the top element in an array to the first. After the for statement comes the block of code that will be executed repeatedly as long as the test condition is true. This block of code is contained within curly braces. If the condition is never true, even at the first test of the loop condition, the code inside the for loop will be skipped over and never executed. Putting all this together, how does the for loop work? Execute initialization part of the for statement. Check the test condition. If true, continue. If not, exit the for statement. Execute code in the block after the for statement. Execute the increment part of the for statement. Repeat steps 2 through 4 until the test condition is false. And we reach the next exercise, which is chapter 3, example 4.html. Doc type, HTML, go here for language, English, go for head, title, chapter 3, sample 4, use a body for the script, click enter, and we see what's happening here. So we see variable the parent is equals to, sorry, 1 2 2 1 2 3 2 minus 459, oh, 0.15. Okay, a variable deg centigrade. Okay, it's another array. Var loop counter for loop counter equals 0. Loop counter less or equal than 2. Loop counter dexcent weird place for the curly braces. Okay. Now I'm gonna fight that, I guess. Oh, wait a minute. I forgot something very important. Plus plus. the accent loop counter equals 5 divided by 9 times the degree Fahrenheit loop counter minus 32. For loop counter equals 2 loop counter greater than 0 loop counter minus minus. Okay, document.write value plus loop counter plus was plus deg Fahrenheit loop counter plus degrees Fahrenheit go. All right. We keep in this loop as well. Document.write which is the accent loop counter plus degrees centigrade break line Okay, let's see if this works. Go to the folder and we go to the so that should be it. Okay, value 2 was minus 459. Okay, I think we got it. That's the result that we got, so it's fine. So the first task is to declare the variables you are going to use. First, you declare and initialize the Fahrenheit to contain an array of the three values, 212, 32, minus 49. Next, you declare the centigrade as an empty array. Finally, you declare loop counter and will use it to keep track of which array index you are accessing during your looping. Okay. In the first line, you start by initializing the loop counter to 0. Then the for loop's test condition. Loop counter is checked. If this condition is true, the loop executes for the first time. After the code inside the curly braces has executed, the incrementing part of the for loop, loop counter plus plus, will be executed, and then the test condition will be reevaluated. If it's still true, another execution of the loop code is performed. This continues until the for loop's test condition evaluates to false, at which point looping will end and the first statement after the closing curly brace will be executed. The code inside the curly braces is the equation you saw in earlier examples. Only this time you are placing its result into the dexent array, with the index being the value of loop counter. In the second for loop, you write the results contained in the dexent array to the screen. For loop counter equals to 2, loop counter greater or equals to 0, loop counter minus minus. This time you are counting down from 2 to 0. The variable loop counter is initialized to 2 and the loop condition remains true until the loop counter is less than 0. This time, loop counter is actually decremented each time rather than incremented by means of loop counter. Again, loop counter is serving a dual purpose. It keeps count of how many loops you have done and also provides the index position in the array. Okay, the for in loop. This loop enables you to loop through each element in the array without having to know how many elements the array actually contains. In plain English, what this loop says is for each element in the array, execute some code. Rather than having to work out the index number of each element, the for in loop does it for you and automatically moves to the next index with each iteration. For indexing array name. So in this code extract index is a variable you declare prior to the loop, which will automatically be populated with the next index value in the array. Array name is a name of the variable holding the array you want to loop through. Let's look at an example to make things clearer. You define an array and initialize it with three values. Var my array, Paul, Paula, Pauline. To access each element using a conventional for loop, you'd write this. For var loop counter equals 0, loop counter less 3, loop counter plus plus. Segment right, my array loop counter. To do exactly the same thing with the for loop, the for in loop, you write this. For variable element index in my array, document write my array element index inside array brackets. As you can see, the code in the second example is a little clearer, as well as shorter. Both methods work equally well and will iterate through 3 times. However, if you increase the size of the array, for example, by adding the element myArray 3, Philip, the first method which will still loop only through the first 3 elements in the array, whereas the second method will loop through all 4 elements. The while loop. Whereas the for loop is used for looping a certain number of times, the while loop enables you to test a condition and keep on looping while it's true. The for loop is useful when you know how many times you need to loop. For example, when you are looping through an array that you know has a certain number of elements, the while loop is more useful when you don't know how many times you will need to loop. For example, if you are looping through an array of temperature values and want to continue looping when the temperature value contained in the array element is less than 100, you will need to use the while statement. Let's take a look at the structure of the while statement as illustrated in figure 3.12. Condition, keep looping while this condition is still true. While the extent is not equal to 100, some code. Code loop through. That's the biggest image we have seen in this book, actually. I appreciate that. You can see that the while loop has fewer parts to it than the for loop. The while loop consists of a condition which, if it evaluates to true, causes the block of code inside the curly braces to execute once. Then the condition is re-evaluated. If it is still true, the code is executed again. The condition is re-evaluated, and so on until the condition evaluates to false. Cool. One thing to watch out for this is that if the condition is false to start with, the while loop never executes. For example, var dexent equals to 100, while dexent is not equals to 100, some code. Here the loop will run if dexent does not equal 100. However, because dexent is 100, the condition is false and the code never executes. In practice, you would normally expect the loop to execute once. Whether it executes again will depend on what the code inside the loop has done to variables involved in the loop. condition, for example, var dexcent, decfaren, var loop counter, while loop counter dexcent, or the loop will execute so long as loop counter is less than 3. It's the code inside the loop counter that increments loop counter and will eventually cause loop counter 3 to be false, so that the loop stops. Execution will then continue on the first line after the closing brace of the while statement. Something to watch out for is the infinite loop, a loop that will never end. Suppose you forgot to include the loop counter plus plus line in the code. Leaving this line out would mean the loop counter will remain at 0. So the condition loop counter will always be true and the loop will continue until the user gets bored and cross and shuts down her browser. However, it is an easy mistake to make and one that JavaScript won't warn you about. It's not just missing lines that can cause infinite loops, but also mistakes inside the loops for code. For example, variable test variable 0 while test variable is less or equal than 10, alert the test variable is plus test variable plus plus. If test variable is equal to 10, alert the last loop. See if you can spot the deliberate mistake that leads to an infinite loop. Yes, it's the if statement that will cause this code to go on forever. Instead of using instead of using the equal as a comparison, equal operator as a comparison operators in the condition of the if statement, you put the assign operator. So the test variable is set to 10 again in each loop, despite the line test variable plus plus. This means that the start of each loop, the test condition always evaluates to true because 10 is less than or equal to 10. Put the extra in the make if test variable and everything is fine. The do while loop. With the while loop, you saw that the code inside the loop only executes if the condition is true. If it is false, the code never executes, and execution instead of moves to the first line after the while loop. However, there may be times when you want the code in the while loop to execute at least once, regardless of whether the condition in the while statement evaluates to true. It might even be that some code inside the while loop needs to be executed before you can test the while statement condition. It's situations like this for which the do while loop is ideal. Look at an example in which you want to get the user's age via a prompt box. You want to show the prompt box, but also make sure that what the user has entered is a number. Variable user age, do user age equals prompt, please enter your age, while is user age true. The code line within the loop user age equals prompt, please enter your age, will be executed regardless of the while statement's condition. This is because the condition is not checked until the one loop has been executed. If the condition is true, the code is looped through again. If it's false, looping stops. Note that within the while statement's condition, you are using the isNaN function that you saw in chapter 2. This checks whether the user age variable's value is NaN, not a number. If it is not a number, the condition returns a value of true. Otherwise, it returns false. As you can see from the example, it enables you to test the user input to ensure the right data has been entered. The user might lie about his age, but at least you know he entered a number. The do while loop is fairly rare. There's not much you can do without it, so it's best avoided unless really necessary. The break and continue statements. Okay, you met the break statement earlier when you looked at the switch statement. Its function inside a switch statement is to stop code execution and move execution to the next line of code after the closing curly brace of the switch statement. However, you can also use the break statement as part of the for and while loops when you want to exit a loop prematurely. For example, suppose you are looping through an array as you did in the temperature conversion example, and you hit an invalid value. In this situation, you might want to stop the code in its tracks, notify the user that the data is invalid, and leave the loop. This is one situation where the break statement comes in handy. Let's see how you could change the example, where you converted a series of Fahrenheit values so that if you hit a value that's not a number, you stop the loop and let the user know about the invalid data. Mm, okay. If not a number, the for loop counter. Okay. You have changed the initialization of the dec Fahrenheit array so that it now contains some invalid data. Then inside the for loop, you add an if statement to check whether the data in the dec Fahrenheit array is not a number. You do this by means of the is not a number function. It returns true if the value passed to it in the parentheses. Here, the foreign loop counter is not a number. If the value is not a number, you tell the user where in the array you have the invalid data. Then you break out of the for loop altogether. Using the break statement, and code execution continues on the first line after the end of the statement, on the for statement. That's the break statement. But what about continue? The continue statement is similar to break in that it stops the execution of a loop at the point where it is found, but instead of leaving the loop, it starts execution at the next iteration, starting with the for or while statement's condition being reevaluated, just as if the last line of the loop's code had been reached. In the break example, it was all or nothing. If even one piece of data was invalid, you broke out of the loop. It might be better if you try to convert all the values in the Fahrenheit, but if you hit an invalid item of data in the array, you notify the user and continue with the next item, rather than giving up as the break statement example does. Just change the break statement to continue. You will still get a message about the invalid data, but the third value will also be converted. Okay. Summary. Ooh, we reached the end of the chapter. Let's go. In summary, in this chapter, you continued your look at the core of the JavaScript language and its syntax. The chapter looked at the following: decision making with the if and switch statement. The ability to make decisions is essentially what gives the code its intelligence. Based on whether a condition is true or false, you can decide on a course of action to follow. Comparison operators. The comparison operators compare the value on the left of the operator, left-hand side LHS, with the value on the right of the operator, right-hand side RHS, and return a Boolean value. Here is a list of the main comparison operators. Uh-huh, uh-huh, uh-huh. The if statement. Using the if statement, you can choose to execute a block of code when a condition is true. The if statement has a test condition specified in parentheses. If this condition evaluates the true, the code after the if statement will execute. The else statement, if you want code to execute when the if statement is false, you can use the else statement that appears after the if statement. Logical operators. To combine conditions, you can use three logical operators: and, or, and not, represented by an and, a double line, and a exclamation point, respectively. The switch statement this compares the result of an expression with a series of possible cases and is similar in effect to a multiple if statement. Looping with for, in, while, and do while, it's often necessary to repeat a block of code a number of times, something JavaScript enables by looping. The for loop, useful for looping through code a certain number of times. The for loop consists of three parts: the initialization, test condition, and increment part. Looping continues while the test condition is true. Each loop executes the block of code and then executes the increment part of the for loop before re-evaluating the test condition to see if the results of incrementing have changed it. The for in loop is useful when you want to loop through an array without knowing the number of elements in the array. The while loop is useful for looping through some code for as long as a test condition remains true. The do while loop this is similar to a while loop, except that it executes the code once and then keeps executing the code as long as the test condition remains true. Break and continue statements. Sometimes you have a good reason to break out of the loop prematurely, in which case you need to use a break statement. Okay. And we have some exercises. I'm gonna just put one exercise in each 3 seconds. So 3, 2, 1, 3, 2, 1. And we reached the chapter 4, and we have still like 20 minutes to go. Awesome. Okay. I know I'm reading a lot, but you have to bear with me, okay? Functions at scope. Okay, so we reached functions already. So we are about to get into the object-oriented programming here. What you will learn in this chapter: creating your own functions, identifying, creating, and using global and local variables, and using functions as value. I'm gonna pause this over here because I need to make the folder for this chapter. So I'm gonna wait for me for a second. All right, let's get going with the. You can find the code in this also as well, and wiley.com, beginning javascript.com. If you want to go at your own pace, of course, I'm just doing this on my own pace. Um, but yeah, that's a full disclaimer, of course. A function is something that performs a particular task. Take a pocket calculator as an example. It performs lots of basic calculations, such as addition and subtraction. However, many also have function keys that perform more complex operations. For example, some calculators have a button for calculating the square root of a number, and others even provide statistical functions, such as the calculation of an average. Most of these functions could be done with the basic mathematical operations of add, subtract, multiply, and divide, but it might take a lot of steps. It's much simpler for the user if she only needs to press one button. All she needs to do is provide the data, numbers in this case, and the function keys, that's the rest. Functions in JavaScript work a little like the functions buttons on a pocket calculator. They encapsulate a block of code that performs a certain task. Over the course of the book, so far, you have come across a number of handy built-in functions that perform a certain task, such as the parse integer and parse float functions, which convert strings to numbers, and the is not a number function, which tells you whether a particular value can be converted to a number. Some of these functions are return data, such as parse integer, which returns an integer number. Others simply perform an action but return no data. You will also notice that some functions can be passed data, whereas others cannot. For example, the is not a number function needs to be passed some data, which it checks to see if it is not a number. The data that a function requires to be passed are known as its parameter. As you work your way through the book, you'll be coming across many more useful built-in functions. But wouldn't it be great to be able to write your own functions? After you have worked out, written and debugged a block of code to perform a certain task, it would be nice to be able to call it again and again when you need it. JavaScript enables us to do just that, and this is what you will be concentrating on in this section. Creating your own function. Creating and using your own function is very simple. So function convert to centigrade Fahrenheit, var dexcent, return dexcent. I don't know about you, but I'm getting tired of the same example. I will to see more examples, which we're gonna do later. You will probably already realize what this function does and how the code works. Yes, it's the infamous Fahrenheit to centigrade conversion code again. Each function you define in JavaScript must be given a unique name for that particular page. The name comes immediately after the function keyword. To make life easier for yourself, try using meaningful names so that when you see them being used later in your code, you will know exactly what they do. For example, a function that takes as its parameter someone's birthday and today's date and returns the person's age could be called a getAge. However, the names you can use are limited, much as variable names are. For example, you can't use words reserved by JavaScript. You can't call your function if or while. The parameters for the functions are given in parentheses after the function's name. A parameter is just an item of data that the function needs to be given in order to do its job. Usually, not passing the required parameters will result in an error. A function can have zero or more parameters, though even if has no parameters, you must still put the open and close parenthesis after its name. For example, the top of your function definition must look like the following. Function my non-param function. You then write code, which the function will execute when called on to do so. All the function code must be put in a block with a pair of curly braces. Functions also enable you to return a value from a function to the code that called it. You use the return statement to return a value. In the example function given earlier, you return the value of the variable the centigrade, which you have just calculated. You don't have to return a value if you don't want it, but it's important to note that every function returns a value even if you don't use the return statement. Functions that do not explicitly return a value, that is, return a value with the return statement, returned undefined. When JavaScript comes across a return statement in a function, it treats it a bit like a break statement in a for loop. It exits as a function, returning any value specified after the returned keyword. You'll probably find it useful to build up a library of functions that you use frequently in JavaScript code, which you can reference in your pages. Having created your functions, how do you use them? Unlike the code you have seen so far, which executes when JavaScript reaches that line, functions only execute if you ask them to, which is termed calling or invoking the function. You call a function by writing its name at the point where you want it to be called and making sure that you pass any parameters it needs, separated by commas, for example. My temperature convert to centigrade to 12. Okay, this line calls the convert to centigrade function you saw earlier, passing to 12 as the parameter and storing the return value from the function in the my temp variable. Have a go at creating your own functions now, taking a closer look at how parameters are passed. Parameters passing can be a bit confusing. You will first create a simple function that takes just one parameter and writes it to the page in a friendly welcoming string. First, you need to think of a name for your function. A short but descriptive name is write user welcome. Now you need to define what a parameters the function expects to be passed. There's only one parameter, the username. Defining parameters is a little like defining variables. You need to stick to the same rules for naming, so that means no spaces, special characters, or reserved words. Let's call your parameter username. You need to add it inside a parenthesis to the end of the function name. Note that you don't put a semicolon at the end of the line. Function, write user welcome username. Okay. Now you have defined your function name and its parameters. All that's left is to create the function body. That is the code that will be executed when the function is called. You mark out this part of the function by wrapping it in curly braces. The code is simply enough. You write out a message to the web page using document write. You can see that username is used just as you would use any normal variable. In fact, it's best to think of parameters as normal variables. The value that the parameters has will be that specified by the JavaScript code where the function was called. Let's see how you would call this function. Write user welcome Paul. Simple, really just write the name of the function you want to call and then in parentheses add the data to be passed to each of the parameters. Here just one piece. When the code in the function is executed, the variable username used in the body of the function code will contain the text Paul. Suppose you wanted to pass two parameters to your function, what would you need to change? Well, first you would have to alter the function definition. Imagine that the second parameter will hold the user's age. You could call it user age because that makes it pretty clear what parameters data represents. Here is the new code. Okay. You have added a line to the body of the function that uses the parameter you have added. To call the function, you would write the following. Write user welcome, Paul31. Okay. Ah. right, guys, let's try to do this. ch4 sample1.html. Fahrenheit, centigrades, come to me one more time. Okay. Chapter 4, sample 1. We have body script function convert to centigrade parameter deg rn variable deg cent equals 5 9 times deg rn minus 32 return deg cent variable deg rn equals is an array to 12 32 minus 459.15 variable accent And with oh wait a minute, there's an error here. Wait a minute. It's an error. Let me get to here. So what's wrong? Where? Oh, there. Oh, there you go. Okay, we save. Go to the there, and also we're going to the page. And if we look the book, it's going to be, I think, the same thing, right? Apparently it is. It doesn't show anything, so probably it's going to be the same thing, but it's like the same implementation. If you're using a number of separate script blocks in the page, it's very important that the function be defined before any script calls it. If you have a number of functions, you may want to put them all in their own script file and load it before all other scripts. That way you know where to find all your functions, and you can be sure that they have been declared before they have been used. Should be pretty familiar with how decoding the function works. You declare a variable dexent to your calculation or return dexent back to the calling. Call the function parameters. Okay, on the function declaration is a code that executes when the page loads. Okay, I think we all agree on that, right? Okay, and with that, because there's some page plugin here. With that, guys, we reached the end of this particular chapter of the code, of the course. We finally got into chapter 4, and we are one step closer to the object-oriented programming. Functions are everywhere, and we're going to see functions also. I think we already saw functions in Python already, right? So we already got functions into JavaScript, and you're going to see a lot more into it. Stay tuned because I'm going to make more content in JavaScript this day. I'm going to, right now is Saturday 26th of October. So I'm going to stop this video, gonna edit it, and then gonna upload it to YouTube, to upload it this day, and then I'm gonna make more content, 2 more courses for JavaScript, and then gonna upload it for the following Wednesday. So stay tuned because this is gonna be a pack load day of JavaScript. So thank you very much, guys, and see you guys next time. Bye bye.